One of the most silly questions that I get on this channel is what is the ROI on a dehumidifier? Because you just have to take care of it. It's not, you're not going to get this money back. And if you really wanted to make a list of all the things that have to do with durability and the not just the comfort and the humidity, but human health, the list of like expenses on the side of not handling humidity would be very long. So I am going to show you something really amazing. First of all, this is my friend Tim Destasio. Tim, thank you very much for being here.
Thanks for having me.
You have been doing an experiment on your brand new house for the last year, it sounds like, on comparing dehumidifier drying to reheat drying, which is this kind of like it's a buzzword out there right now. You guys should go and check out Tim's channel. Every Saturday, he's got a psychrometric chart on the board behind him. He does a little psychrometric Saturdays. Can you kind of like give us a basic on where people can find you?
Yeah, so I have a YouTube channel also, just like you. It's in all the social media platforms, Instagram, Facebook, and YouTube. It's Tim Destasio HVAC, one word, Tim
Good
Destasio
job.
HVAC. And then you can
That's
find me
exhausting,
out on
all of
LinkedIn.
them.
Oh yeah, yeah, it is. My company name is Comfort Science Solutions. I'm based out of North Carolina, coastal North Carolina.
Awesome. And Tim is doing HVAC designs for people, so you can get those all over the country from him. So please do feel free to reach out if you're looking for a
Thank you.
manual J or HVAC design. There needs to be more people who can do that. So can you please give us a big scale, like overview of what your house is like that we're going to be dialing in on this dehu reheat thing?
Yeah, so I had a house built in 2023, and I used a local builder that we thought was he did good framing work, he did good work, just wasn't a high performance builder. And we were trying to keep things simple. We had set a budget out, but I did want a high performance home. And so I did a few things to make it perform a little bit better than a house built by code. So here, of course, I'm in coastal North Carolina, humid environment, warm, humid climate. The first thing that I did is I used a zip system sheathing and made sure all the seams were taped really, really well. We still use bad insulation that the builder provided, but I locked in the envelope using not only zip system sheathing, and then we spray foamed our roof deck. And then I was just really, really careful about air sealing the rest of the house. Sam Myers from Retrotech, he lives nearby. He came over. We blower door tested the house during its rough phase, and then we made some more air sealing, and then we, of course, tested it at the very end. So air sealing was my main concern, sealing the thermal envelope. And then for HVAC, I just installed a Bosch inverter heat pump, which has a little bit different algorithm and how it stages its cooling. And then I used a ventilating dehumidifier for ventilation. And that was not only an effort to try to save cost on an ERV over a ventilating dehumidifier, I was able to combine the ventilation and the dehumidification as well as the filtration. So we actually taken care of all three of the pillars of indoor air quality that we talk about so much with that one device. And so I have a Santa Fe Ultra 70 ventilating dehumidifier, and it's controlled by the Haven IAQ control system, which means that we ventilate on demand. So we only sprinkle in fresh air when we need to, and we dehumidify, of course, on demand. And when we're ventilating, we're passing the fresh air and mixing it in with the dehumidifier return. And so we're passing that air through the dehumidifier, the MERV 13 filter that's inside of it. Then we distribute it into the ducts. But then I set out to understand the impact of having a dehumidifier versus using the heat pump that you already have to dehumidify for you. So, of course, we know that when you run air conditioning, you're going to dehumidify as a side point. It's not the main job of the air conditioner, but it's something nice that happens that we need, especially in humid climate. So sometimes, though, it's not enough, as you've talked about in your channel. And there are plenty of times when we are not running air conditioning as much, but we have every bit of the latent load. And so, what do we do
Like right
about that?
now, for example?
Exactly. Yeah, right now, I mean, here we are in November. I think today's a pretty dry day, but the first couple weeks in November, we actually had outdoor dew points well into the 60s, in the mid 60s. And so that's dehumidification weather. Anytime the dew point outside is considerably higher than the desired dew point inside of somewhere in the mid 50s, then you are going to probably need to dehumidify if your house leaks or if it ventilates. If we're pulling in that outside air either accidentally or on purpose, we're going to need to deal with that moisture.
And again,
So, mhm.
if you're not leaky or ventilating, then you're thinking about ROI in that kind of unhealthy way, where it's just like you just have to do this stuff because
Right.
this is what life is.
So this is my HVAC system up in my attic, and
Very
you
pretty.
can see it's very busy around here. I am not only have ductwork going from my dehumidifier back into my HVAC, but I also have a fresh air duct, and then I have another set of ductwork that I use to dry my attic using that same dehumidifier. So I'm with you, Corbett. I don't like the idea of breathing spray foam insulation, and so because I was also cheap. I wanted to use the same dehumidifier to do both. So I have a damper system that switches over every now and then, and I either dry my attic or I dry my house. So that's some more of the other busy ductwork that you see up there. So I've got a ton of controls up there. And I'm not only looking at my Haven indoor air quality, but I'm also integrating things from my AirThings room indoor air quality sensor, and I'm using If This Then That, which is a home automation platform, to also sprinkle in some outputs to my ventilating dehumidifier based on additional stuff like carbon dioxide and even particulate matter. So I'm doing a lot here, but we're talking about reheat dehumidification versus a dedicated dehumidifier. So I came across some advice online that where contractors are having good success using something like a communicating HVAC system, communicating heat pump that had reheat dehumidification built into it. So reheat dehumidification is we're using the compressor that's already in the heat pump. You've already paid for this heat pump. You've installed it. You've got this compressor. We know that dehumidification is a nice byproduct of air conditioning. So you're reusing that, but we know that there are times when you need to run the cooling to dehumidify the house longer than you would want to run the cooling to cool the house. And so you have two choices. Well, we either stop dehumidifying because we're going to get cold, or we continue dehumidifying and we try to sprinkle in some electric strip reheat to keep that compressor running, keep dehumidifying, but we don't get cold. We're reheating that air. So it's really important for any reheat strategy to have the heat source after the cooling coil. We have to have it after the cooling coil. You can't have it before it because all we're doing is throwing a bunch of heat on the cooling coil. The cooling coil temperature raises, and now we're above dew point. Now we're not even dehumidifying. And so it's really important for it to be reheat, not preheat.
And that's one of the reasons why we don't dump dehumidified air into the return before
Yes.
the AC. It looks like your 70 pint per day dehumidifier is pulling out of the return, and then
Yes.
it's dehumidifying and then dumping into the supply. So they're running kind of like
Right.
tandem to each other. Yeah.
I actually have some more nerdery here for you. So I also like dabbling in SketchUp. And so I did a SketchUp 3D of not my exact setup, but sort of what a ventilating dehumidifier is. So here we have a heat pump system, and we can see we have a fresh air intake right there. Here's another look inside the house. And so we're going to pull in that fresh air through the dehumidifier. In fact, I have a better view. And then essentially what I'm doing is I'm pulling a return from my return plenum. It's mixing in with the dehumidifier. And then we're dumping the supply back into the supply plenum. And we're trying to do it at a 45-degree angle so that those two air streams merge instead of collide.
First of all, Tim's doing this. I've seen some of your HVAC designs, and you're doing this like on all of your HVAC
No, no,
designs?
no, no. This is just for
Okay,
me.
good. All right.
This takes
It's
way
like
too
he's
long
making me
for
look
me.
bad a little bit. So
Uh,
first of all, that's very nice. And secondly, the devil is in the detail. It's like, what duct connection are you going to make? How many
yeah,
elbows are there? How close is all this stuff together? I think that that's
yeah.
really a beautiful example of that.
Appreciate it. This is a CAD detail similar to what I would provide um, in my deliverables when I design a house. And this shows my two damper system. So this is pulling in when I'm in attic drying mode, I'm going to open this damper, close this damper. So we're going to pull in all attic air. And then instead of dumping it back into the space where we're going to be breathing attic air, this damper will also be closed. This will be open and we will be distributing air into the space. So
So you're both ventilating and dehumidifying the attic space.
Yeah, so
You're
the
diluting it.
ventilation, I'm not really turning off the ventilation during that point. I don't really have an automation for that.
Hmm.
So, and I only do that for a few hours during the day. So we know that moist air is buoyant. It hangs out in the ridge of a encapsulated attic, and then the sun comes out in the afternoon and it drives that moisture out of those wood members. That moisture just kind of hangs out by the ridge. Well, that's the time when I'm actually pulling that moisture through and drying my attic. So I'm pulling my return from near the ridge of the attic, and I'm letting the big dog eat. I'm letting the dehumidifier see that moisture and then dry the attic. And that is only for a few hours of the day during the peak of the day. Because I'm not really worried about my dehumidifier having to dry the house during the peak of the day. My air conditioner should have been sized and designed correctly to do that. And I've tracked this over time, and that's exactly what happens. My dehumidifier doesn't really need to run during the heat of the summer day, but every hot summer day has a muggy summer night. That's when you need dehumidification. So there's a misconception that during the summertime you do not need supplemental dehumidification because it's already hot. And that is true during the middle of the day. But at night, the outdoor temperatures dip below 80 degrees down to 75 degrees, 70 degrees, but the humidity stays up there. You don't have any solar loads. You only have the thermal mass of whatever the house soaked up that's still kind of coming through. And that's it. So your sensible load goes way down, but your latent load is still way up there. And that's actually when we need to be doing more ventilation is when we're at home, laying in bed for 8 straight hours, breathing, and that's when we should be ventilating. We don't really, if we're at work for from 9 to 5, then we're probably not making as many pollutants in the house as when we're at home and then spending all night asleep.
Hmm.
So that's when I run my dehumidifier the most is at night, and then of course during shoulder weather. And it's amazing when you start tracking this stuff, how much low sensible, high latent periods there are in a year. How many hours of that is in the year? When we design an HVAC system, we're designing for the top, excluding the top 1% of outdoor temperature. So that means that 99% of the time, we're actually oversized. And just how oversized are we? And I have a two-stage unit with a variable speed compressor, so it's sort of a hybrid between a solid two-stage and a full inverter system. But there are times when your AC, there just isn't enough sensible load for your AC to run, and but you still need a dehumidifier. What do you do in those cases? And so I have two strategies here. We have a dedicated dehumidifier that we've talked about. You've seen the screenshots I've shared, and it will run and dehumidify when the AC doesn't have to run. And it's sized correctly so that you're getting good long run times. The indoor coil is staying cold. And the nice thing about a dehumidifier is you're not overcooling the building because the dehumidifier is also reheating and it's using the same BTUs of latent heat and sensible heat that it absorbed to get you down to dehumidification. It's taking those BTUs and harnessing them and putting them back into the space in sensible heat so that you can maintain a near constant temperature. So we probably have felt a dehumidifier ductwork, you and me, when we're checking units out, and we know the dehumidifiers put out hot air. And what that is a conversion of sensible and latent heat that it took to get our coil down to dew point and pull that heat out of the air. And we're converting that into sensible heat, plus adding a little bit of wattage for the compressor, and we're putting that back into the space. So there is a little bit of a heat gain there, but we're not wasting those BTUs that we use to convert to moisture removal the way, an air conditioner does. An air conditioner rejects that outside, it's gone forever, and a dehumidifier actually allows us to harness that and so that it adds a little bit of sensible load to the building and it stays running longer, which is helpful. Adding a little bit of sensible load to a building during periods of low sensible heat actually lets your air conditioning run a little bit longer. And your air conditioning is a very effective dehumidifier also. It's a bigger
Much bigger,
dehumidifier, much
way
bigger,
bigger.
has a lot of capacity. So all those are kind of pluses in the dedicated dehumidifier. The other advantage to a dedicated dehumidifier is when it is a ventilating dehumidifier, it um, it also ventilates. It is a constant volume ventilator. And so I can pull a constant amount of CFMs through my fresh air duct when I'm in ventilation mode. I know that when that fresh air damper opens, I am definitely pulling in my case, around 45 CFMs because I have a constant amount of airflow that dehumidifier runs. Well, now let's turn our attention to reheat dehumidification. The units that have integrated reheat dehumidification are mostly communicating heat pumps. Those are great units. They keep they're inverter driven, so we have a compressor that's going to run longer.
Can you clarify, Tim, when you say communicating, like I'm not enough of a nerd in
Okay,
HVAC to know what that means. Is that like a whole class of HVAC? Is it all inverter driven?
yeah. So the way we separate HVAC controls in residential is we either have conventional 24-volt controls. So you send 24 volts out to your indoor fan relay and it comes on. And now within that the controls of the unit, it may vary the speed up and down, but we're distributing a 24-volt signal through the thermostat to relays, contactors, other things that energize and de-energize. A communicating system does not send 24-volt signals, it sends proprietary data. And so when you buy a communicating system, these are the upper tier HVAC systems. So anything, and I don't know whether we can say names on here, but I'll
Sure.
give you an example.
Yeah, go
So
ahead.
Mitsubishi, that is a communicating system. It sends data through one wire. And so Carrier Infinity has a really good reheat dehumidification strategy built into it as an option. But what you're signing up for when you get that is you're stuck with that Carrier Infinity thermostat. Some people love it. I personally would much rather have an Ecobee thermostat with all the nerdy stuff that it gives me as well. So, but let's say that you do want to use reheat dehumidification. The Carrier Infinity system is really good about that. It has an integrated option in there. Yes, you do have to use their proprietary thermostat. It is a high efficiency system. We're talking about, 19, 20, 22 SEER. And it does a really good job. And so when you enable that option, you tell it, okay, I want to maintain, let's say, 50% relative humidity. And when I am cooling and dehumidifying, great, I'm accomplishing both. When I get down to my cooling set point, I'm going to continue to run the compressor on the heat pump, and I'm going to run it in a way that optimizes for dehumidification. And as the temperature in the space cools, I'm going to sprinkle in reheat to bring it back.
And that means, by the way, that you are lowering the CFM of airflow of the air handler and super cooling the coil, right? Just
Right.
not to the point of freezing
Right.
water
You're
on it.
saying, yeah. And it's a very effective, robust dehumidification cycle. They do it very, very well. And so that I think is what we have on that side. That's probably one of the better reheat dehumidification systems out there. Now, for my house, I did not want that system. I didn't want the Infinity system. I didn't want that thermostat. I wanted an Ecobee. So I didn't put that in. But I still wanted to compare the return on investment of purchasing a dehumidifier. So you have the upfront cost there, some installation costs, and you have some energy use. Obviously, a dehumidifier is gonna, there's no free lunch in building science. Moisture is energy. It takes energy to remove it. Your energy bills are going to be a little higher with a dehumidifier versus not having a dehumidifier. So you've got that on one hand. And then you have, on the other hand, the now one advantage of that is you can use any HVAC system you want. You can use a conventional single stage 14 SEER heat pump, air conditioning furnace, like it doesn't matter. This dehumidifier doesn't even know that HVAC system exists. It operates independent of it. So it's great for retrofits in an existing house. Then you have, on the other hand, reheat dehumidification. Now, you either have the high upfront costs of a system like Carrier Infinity that can do that. That's going to cost a lot more than that simple one or two stage 14, 15 SEER unit, on the other hand. So you have that. But then you're not buying an additional dehumidifier. You're not worrying about the cost of ownership, the maintenance, the eventual replacement of it. Dehumidifiers, especially of certain brands, went through a really bad run a few years ago where they were leaking their indoor coils, and so you were losing all the refrigerant out of the system. They weren't effective, and now either you had to replace it on your own dime, or maybe the manufacturer gave you parts, or maybe even a new unit, but you still had to pay for the labor. So now I think it's a lot better. Santa Fe offers a 6-year replacement warranty on their dehumidifier. So you have any issues out of it, they will ship you a new dehumidifier for you to install. So maybe you
And
put it in
having,
your
by
home.
the way, for those of you who are DIY people, Tim is a professional who's worked in installing new systems all the time. I replaced my dehumidifier it was one of the ones that you're describing,
Okay.
and replacing like for like is absolutely something if you're a little bit handy that you can do, because if you
Yeah.
get somebody like Tim to set it up in the first place, all
Hmm.
you do is just copy what he did. You disconnect
Hmm.
the things that he put in there, you put the
Yeah.
new one in, you put it right back where it was. It's like really not that
Right.
hard.
So we know that a reheat dehumidification strategy, because we're using electric strips, we know that those are expensive to run. We know that's going to cost more in energy. We've established that. Everybody accepts that. The question is, how much energy can you buy before you've bought a dehumidifier? And so the average dehumidifier, like on the low end, if we're just putting in a dehumidifier, it's going to start at 5,000 and up. I mean, that's like the smallest dehumidifier they make, and a very simple installation, and a contractor that's not trying to, you know, like rip you off. And then it goes up from there. If there's any kind of complications, it's going to run 6,000, 7,000 on up. So you can actually buy a lot of energy for $6,000, $5,000. And so the argument is, by the time that dehumidifier has ran its through its life, and especially during the time period when dehumidifiers were dying early, you can use what you already have, and it can and there's a return on investment there. So I set out to kind of figure out, okay, how would I do that with my Bosch system? I don't have the Carrier Infinity. How can I compare this? So I came up with a Wi-Fi relay that can integrate with If This Then that home automation platform. And so I created some automations for reheat dehumidification to do exactly what I've described. When we need to dehumidify the house, whenever my humidity in the house is over 50%, then we will run the compressor outside in its most robust dehumidification mode possible. And as the temperature drops in the house, we're going to start sprinkling in electric reheat. Now, is it as effective as a communicating heat pump where all that is integrated, it's designed by engineers? No. But it was the best that I could do with it. There are some conventional 24-volt thermostats out there that offer that as an option. I believe the Honeywell Prestige IAQ, when you put it in commercial mode, has a reheat dehumidification. But I didn't want that thermostat. I want to do it with my Ecobee, and I thought of it as a challenge of, can I create an automation for this? So I did. I created a reheat dehumidification automation.
Tim,
I
before you jump into the
uh
details on the experiment, can you just describe what is this strip heat that you've got? Is it 3K
it
kilowatt or
is
5 kilowatt?
it's 5 kilowatt. I originally installed a 10 kilowatt reheat or heat strip in there, which is two 5Ks together. And what I did is I had way too much strip heat in there. And the reason why I did that is, if for some reason the compressor went out of my heat pump, I wanted to have enough reheat of or heat strips available to heat the home in emergency heat mode. Then, when I actually moved in the house and I started doing actual load calculations based on runtime, I realized that, as we've talked about here on the show, especially on the heating side, your load calculations are way oversized. And what I realize is, there is not a scenario short of the big freeze that killed the woolly mammoth that I am going to need in my climate 10 kW of strip heat. So I simply disabled one bank. So it's just there, it's dormant. And so now I'm running off of five.
Great.
It-
And just to spell it out for people who are not familiar with this, 5 kilowatts of strip heat, you multiply watts by 3.41. So that's 17,000 BTUs per hour. That's basically a ton and a half
yeah,
of air conditioning we're subtracting. So how big
right.
is your air conditioner? Is it two?
It's essentially a 2 ton, but it's backed all the way down to around a ton and a half.
Okay, so
Um,
basically what Tim is describing is we've got a ton and a half of air conditioning. We're subtracting all of that with this 5 kilowatts. If he
right.
had 10, it would be 35,000 BTUs
Yeah. Yeah.
per hour.
And so the goal of reheat is not to heat the air past the neutral temperature. So the neutral temperature is whatever your thermostat set point is. So in my case, it's 75 degrees. I don't want to reheat the air any past 75 degrees because it's not necessary. if I can't reheat it enough to 70 degrees, then I may not be putting enough heat back into the space, and my space may continue to get cold. And so you got to be really careful about how much heat strips you use. I suggest, especially with lower load homes, actually starting out with like a 1 kW, a 3 kW reheat and staging it up from there. And that's what the Carrier Infinity does. It doesn't have one large heater, it has a series of smaller ones, and according to the algorithm, it will stage them up and down. So what I did is I just found that 5 kW, and that pretty much undid the amount of cooling that I was doing, so that I still had a very near neutral temperature. I had around 78-degree discharge temperature coming out of the system into my ducts. And so that allowed for nice long run times. I wasn't having really high temperature swings. I did notice them though, and I tracked them. And when you look at the Ecobee tracking over time, you can see a sawtooth pattern, a hump where it goes up and down, up and down. But it was the best I could do.
And I
So
want to before you get into the experiment, the long-term
yeah.
experiment details, just one more quick nerdy note. How did your system know to turn off the heat strip so that you could go from a 78-degree delivery temperature back down to a 60? Like, were you doing
So
that at the
yeah,
thermostat?
when the if this and that integration looked at my Ecobee thermostat, and when my Ecobee the temperature dipped down around 73 degrees, we engaged reheat to reheat the space. And when it got up to 74, 75 degrees, I was kind of playing around with that set point a little bit, it turned it off.
Hmm,
And so it was running the compressor separately. It was simply looking at RH for the compressor. And then so I had set up some integrations. That's essentially what other controllers are doing is they're running the compressor and the reheat simultaneously and the reheat as needed. So it
great.
was complicated. I mean, I've got a video on how to, and I'm going to create another video on what I did for this controller. And you can do it. And you can try it and you can do the same exact thing that I did, and build one for yourself. And I probably have 50, $60 in materials in it. So it's a lot cheaper than a dedicated dehumidifier for sure.
That's cheaper than any dehumidistat you could possibly buy too. I mean, that's
Right.
yeah.
Yeah. So it was it's pretty amazing what you can do if you understand how HVAC 24-volt control systems work, and you learn a little bit about automation, and then it's just relays closing and opening and you're telling them when to do it.
And so
So
your Bosch is a communicating system or is not?
it's 24-volt controls. It
And
uses
you
an
can't turn
Ecobee,
a
which is
communicating system into a 24-volt system.
some units you can, but you're dumbing them down tremendously. Like all the brains are in the communicating controls. When you turn them into 24 volts, they become either single or two stage units, and there's very little. I mean, they actually make retrofit kits for Mitsubishis where you can run off a 24-volt thermostat, but it becomes a glorified single stage unit. So all those great variable speed riding with the load kind of features that you have out of a communicating inverter system get dumbed down a lot. So I don't recommend it.
Great, thank you.
Yeah. So the test would be for half of each month, I would run using my dedicated dehumidifier. And so I would not be running reheat dehumidification. I would be controlling to 75 degrees indoor temperature, 50 to 55 degrees relative humidity. That was for the 1st through the 15th of every month. On the 16th, I would switch over to my reheat dehumidification and I would run the rest of the month from that. Then when I got my electric bills, because I don't have like a wattage tracker yet, I'm going to be getting like an Emporia pretty soon. But I just looked at my weekly, my utility lets me see every day what my kilowatt usage was. It's not a perfect test, but I just started figuring out how much more it cost me in energy. And what I found was pretty interesting. I had March through October, and honestly, I was still dehumidifying in November, but I just had to cut it off at some point. But I tracked what I just spoke about, and I just tracked what the utility bill was estimated as increasing. So in March, I would have used $30 more in utility cost to run reheat dehumidification. And as we see, as we get farther into cooling season, into the summer, this number goes up. Now in May, it's interesting, it went down, and that was weather related. We sort of had a little bit drive of May. In June, I made a mistake. I accidentally set my reheat dehumidification set point to 60% instead of 50%. But look how much like it dropped. And that taught me something, that if we're willing to try to push the limit and keep our house at 60% RH, obviously dew point's concerned there too. There's a big difference in energy between trying to maintain 50% and 60% in your house at the same temperature. But I made the mistake. I couldn't redo it, so I couldn't go back and undo this. So it was what it was. But then notice what starts happening in July, August, and September. Yes, these are the really humid months that we're all used to. We had a few tropical storms that happened in September and October, but that's where the number really, really jumped. This is the increase in utility bills, the difference between reheat dehumidification and the dedicated dehumidifier. I would have paid $160 more per month, 201 more, 240 more per month. And so we think about, well, why are you paying so much more? If your air conditioning is running more, you should be running more during the day. And the answer was at night. During those night cycles, we still had the latent load. We did not have the sensible load there. And that's what I think a lot of people that are singing the praises of reheat dehumidification don't realize. This is northern bias advice that we were getting. And in southern climates, coastal climates, it is a constant, unrelenting amount of humidity and moisture that we have to deal with. Starts in March and it goes on well into November. And we think about some of those climates up north in really, even if you get on the other side of the Appalachian Mountains, where now the Gulf doesn't have as much of an effect. Yes, you get upper Midwest, you got lake effect. I'm just talking about the effect of the Gulf. It is when you go into March and you look at your outdoor dew points in Ohio, they're really, really low. They're still heating in March. They're still heating in April, sometimes into May. We are dehumidifying in March.
Yeah, Lou Harriman made a really beautiful point about the in a lot of climates that you're describing right now, the dew point tracks with the dry bulb temperature, with the outdoor temperature basically, which is against what people like Tim and I studied when we study psychrometrics. It's like, oh, the temperature goes up, relative humidity goes down because
Right.
the moisture is the same. But what
Yeah.
Tim's describing is in the daytime, dehumidification will be needed a little bit, but then like once it gets to a certain point, we don't need it so much anymore. And then at night, because the AC is taking over, and then at night, the dew point is going to drop down because the temperature drops. And where
Yeah.
we live, you're on the coast in
North
Wilmington, right?
Carolina. Yeah. Yeah.
And in
Um,
Atlanta and in Florida, you're going to have like a constant humidity that actually
right.
tracks night to day.
Yeah, there aren't really periods where the house gets to dry out between March and October. It's unrelenting. Your outdoor dew point is always, there's more grains of moisture outside than you want for that entire period. Um, can you see
And then
this
it rains
line?
too
Yeah, and it rained.
on
We get
top of that.
hurricanes. We get tropical storms. We had a flash flood in September that was a 1,000-year flood here, and
Mm,
it wasn't even a named storm. It was just something that popped off the coast and came and it dumped, it flooded, it washed out roads. We had 4 feet of water in some places. It was unbelievable.
wow.
People died. Like it was, and the thing just popped up. I mean, yes, our climate is starting to do things it never used to do. So I essentially made a line graph off of that chart and we tracked it across the summer. And so we see that really big jump starting in June and it peaks in September because we've got all the dew point, but we don't have the sensible heat. And so we do see, like, if we're running a dedicated dehumidifier, the blue line, we do see it peak, but it kind of, maintains sort of more of a flat line. But with reheat dehumidification, we see a jump. And so if you're going to use that strategy, if you're a contractor, you're going to sell that strategy, you've got to be prepared. You have to prepare your client for that. Because who wants to install a 20 SEER system and pay more in electric bills? Now, I don't know what the Carrier Infinity or some of the other brands that do that, they're obviously doing a better job at reheat than what I'm doing.
Let me push back just
Okay.
as an idea. You know more about it than I do, but like it seems like using a 1 kilowatt or and I don't even know if that exists. A 3 kilowatt is the smallest that Mitsubishi
Mhm.
has, but turning a 3 kilowatt on and having it run for longer than your 5 kilowatt is turning on and off. It's just kilowatts. Like, isn't it one
Right.
one
It
basically?
is. It is. There's not. Yeah, it's not like air
Could they
conditioning
really
where
be
it's a
that much better at it
no,
with that
I
programming?
think the dehumidification cycles with those they can run a colder coil
Hmm.
than what I'm able to do. Now I was able to optimize my Bosch unit to dehumidify very well. And so there's this huge thing online about, and some of the same people giving that northern bias advice about reheat dehumidification also try to put a Bosch unit in. They couldn't make it work. And I think it's just because they didn't know how to set it up. Because Jim
It is
Berg
complicated, right?
it is very complicated, but Jim Bergman, HVAC legend, he has a similar system. He went through a lot of, Jim Bergman's going to nerd out on it. I was following his content, and I'm like, yeah, I think I can make that work on mine too. So I'm able to get really good dehumidification, and I've got sensors all over my system, and I'm able to quantify the sensible and latent capacity in real time on my system, and I'm able to get very good dehumidification out of mine. The Carrier Infinity and some of those other brands, they're probably doing a slightly better job just because they can, or they may not be. I mean, are we really tracking it? They have the ability, there's the potential there for them running an indoor coil just above freezing temperature, like 33 degrees. So they can ride that line. Whereas my Bosch is probably running a 43 to maybe a 40-degree coil.
Hmm.
But so the colder your coil, the more dehumidification you're going to get, but the more energy you're going to spend because it takes energy to pull that coil down just a few more degrees. So it isn't a perfect test. I wasn't using the equipment that some of those folks that are giving that advice were given. So and I recognize that, but the difference is astonishing. So at the end of the summer, I paid 768 estimated dollars more had I ran reheat dehumidification than a dedicated dehumidifier. So if you pay $5,000 on the low end for a dehumidifier, it takes 6.5 years for it to pay you back. I think out of this entire podcast is probably the best soundbite right there. It would have
Yeah.
taken at this rate 6.5 years. Well, will a dehumidifier last longer than 6.5 years? We hope so. Santa Fe is warranting them for 6 years.
6 years.
We
Yeah.
hope so.
Hmm.
So yes, it is a very valid point that these two strategies are worth comparing. I think my conclusion at the end of it was I compare it to a boxing match. This wasn't a knockout decision. This was a split decision by by technicality or by points. And I think in the more humid climate you're in, the more leaky your house is, the drier a house you want to maintain, the warmer house that you want to maintain that's going to need more reheat, the more ventilation you run. Um, all those are factors that will cause that um, energy usage, that utility bill difference to get bigger.
Hmm.
If you are in a drier climate, a tighter house, all those things will help you. But let's think about this. I'm in a really wet climate, but I have a really tight envelope. I ventilate, but I ventilate on demand. So
And
there,
when you ventilate, you're ventilating 45 CFM. Do you know what the
right.
ASHRAE 62.2 standard for your house is?
It would have been around 65 to 85, depending on how many people I would have put in the house. I have a
Right.
three-bedroom house, but it's just my wife and I.
Right. So 3 bedrooms, we would say for everybody who's wondering about this, 4 people.
Four people.
Tim's
Right.
really got two.
Yeah.
The ASHRAE standard would say 65 minimum with 2 people, but
Right.
he's able to run it at 45. So if you're running an ERV nonstop, you're in a different boat. Like it sounds
Yeah.
like would you agree that that would be a harder vote for the DHU in that case because of that never ending continuous ventilation?
Yeah, because an ERV is going to ventilate constantly, but it's also going to um, 65%, 75% effectiveness. So now there's not as much latent heat, latent load to deal with. The bottom line is anything that makes your latent load higher is going to bode better for the dehumidifier versus the reheat dehumidification. So people in a northern climate that only have 3 months max of true dehumidification needs, the numbers probably speak a lot better for the reheat dehumidifier.
Interesting.
Um, yeah. So something else to consider also is let's go back to ventilation rate. I'm running whenever my fresh air damper decides to open because my Haven or my automations tell it to open, I'm pulling in around 45 CFMs constant. It doesn't fluctuate up or down because my dehumidifier is pulling that in. My dehumidifier fan runs all the time and it runs constantly. So either it's recirculating return air through the dehumidifier, cleaning it up through the MERV 13, or it's mixing outside air in with that. But it's a constant 45 CFM. A communicating system, unless I understand their algorithms incorrectly, communicating system, your blower speed goes up and down with the load. Okay, it has to. And so when you open up a fresh air damper, you're also, and you don't have an ERV, you don't have a ventilator, you just have a damper running into your return duct, which is, not a great idea anyway. Your CFMs are going to be at the mercy of your blower speed. So if you want a constant ventilation rate, you have to purchase a ventilator. Well, now you've just spent more money. So now, again, we're looking at cost comparisons. That's why I think that a dedicated dehumidifier checks a lot of the boxes as an ERV does. But we know that even with an ERV, you still need a dehumidifier anyway. So, like for my house, it made sense. I have a small house, my ventilation rates are low. I have a tight house, but it's not so tight that I can't exfiltrate a little bit of air out. I'm not doing like a passive house strategy where I'm really worried about my energy bills. Energy is low. I don't care if I waste a little bit of conditioned air out through exfiltration. Ventilating dehumidifier is a good strategy for that type of home. But when we're comparing reheat versus dedicated dehumidification, the northern climates probably don't need as much dehumidification. They don't have that unrelenting heat. And unless you've lived here, unless you've operated a business in comfort and building science and HVAC here, you don't understand
It's
what
really
it's
hard to
like.
tell people.
It is
Yeah,
a
you got to feel
war.
it.
August is like you're living in an ocean, and I just cannot explain that to people because the house becomes a sponge, and from March to the end of October into November, you are soaking in moisture.
Mm.
You don't get a chance where the sponge gets naturally wrung out because the outdoor weather dries out.
Let me put one more little twist on this
Mhm.
story that Tim is wrapping up for us. Reheat depends on you having electric strip backup heat.
Mhm.
And California, Tim is part of our Patreon group. And in that Patreon group is a guy named Luke Morton, who is a Title 24, which basically means he helps people navigate the building code, the energy code out in California. And California is so incredibly, oh, it's like oversaturated as far as their power goes that they are about to roll in a code rule that says that basically we're just trying to do away with all strip heat. We want all heat pumps to be able to just handle anything the weather can possibly throw at it without any backup. And that means you wouldn't even have the strip heat because a place like California, it would be a nightmare for them to have high humidity, low temperature where everybody's reheat kicks on at the same time just to dehumidify. So in a
Right.
place like that, just FYI, there may be rules coming that are like
Yeah.
going to keep you from making that decision if you wanted to experiment with it like Tim did.
Yeah.
But I think, there are tools out there that do this. Dehumidifiers are specifically designed for this. Let me ask you one last question here. Um, Reheat, Brad Lemley, one of my buddies from Tampa, um, said that he's been working a lot on reheat in commercial, and they use coils, like compressor driven coils, to do
Yes.
reheat and that's the only way that
Yes.
it can be really like cost effective.
Right.
Is
Right.
there a way, like, what would you think about installing another smaller heat pump just to do reheat? Is that an insane idea, or is that like, oh, worth thinking about?
I think that's probably not the way that you would want to do it. The way that they're doing it in commercial world, because I came from commercial industrial, they are running a third with the split system. You'd have to run a third copper pipe from the outdoor unit to the indoor unit to put in. It's called hot gas reheat. And they're taking the compressor discharge and instead of dispelling it and it's gone forever outside, they're using that for reheat and then tying it back in. And that's essentially what a dehumidifier does. And so it's a costly retrofit cost, but and there are not really kits that specialize in doing it, so you're sort of customizing it. But yeah, hot gas reheat is incredibly efficient. That's the way to do it. The only thing you have to consider, obviously, you have to run another copper pipe. There's some controls. There's another coil that you've got that's got a static pressure drop that you have to design for. So yeah, that would be an awesome strategy, and I wish that we would see more of it. And just
I mean,
going back,
if you didn't even attempt that, I would assume that it's way beyond the
I mean,
capability of
I'm
most
yeah,
people.
and the thing is, because of the inverter and algorithms in my Bosch unit, I haven't wrapped my head around what my Bosch is going to think when it starts. Because the Bosch has sensors and it's varying the compressor speed and outdoor fan speed based on a lot of internal stuff. It gets a 24-volt signal that tells it to come on, and then there's a lot of math going on in the background, and I just don't think I fully understand that yet to try it. But it's don't put it past me.
Okay.
Um, and I will say that Florida, it is against the energy code to use electric strip heat. I know in commercial settings, and so they already know this is like a horrible strategy for humid environments. So just going back to your comment about California, like I'm not recommending this. Um, and I just have a few final conclusions. I know you're wanting to wrap up, so however you want to
No,
to
yeah, go for it.
yeah, okay. So a lot of the advice that I give is for contractors, but I think homeowners can benefit from it. If you are a contractor and you're vacillating between reheat dehumidification and a dedicated dehumidifier, some things to consider. If you sell a job and you promise them, I'm putting in a really efficient heat pump and we're going to make it a reheat dehumidifier so you don't have to pay me for a dehumidifier, and you don't prepare them for the electric bills, they're not going to be happy with you. They're going to see their bills either stay the same because you went with a more efficient unit, but then you lost all that efficiency in reheat, or it's going to go higher. And so you've got to communicate well. Another thing to consider is a lot of people don't have the upfront money to pay for an HVAC retrofit, and so they finance it. You can finance that extra five, $6,000 for a dehumidifier, gets rolled into your financing, whatever that adds to it, but it's affordable. You can finance that. You cannot finance electric bills. And so you sell somebody a job, or you're as the end user, you pay for that. And then now you're stuck with having, I mean, my bills were in September, I had a $340 electric bill where I could have had a $100 electric bill. How much of that, there's an intangible annoyance with that you've got to consider, that you've got to factor into this. So we have to be really careful about letting people make decisions that they don't fully understand the implications of. So communication and doing the math, understanding the trends. This wasn't a perfect test, a lot of flaws in it, but it helped me maybe not quantify, but it helped me qualify the trends. And for me, my conclusion is I'm going to stick with a dedicated dehumidifier until, at least in my climate. And that's the advice that I'm going to give people. Now, if you've got a client that cannot afford, you got a retrofit system, they've got an HVAC system that has not reached end of life, it's not going anywhere, and now you're telling them you have high humidity problems, we need to always be giving advice to seal the envelope. Every dehumidification conversation needs to have a weatherization conversation attached to it. But you've got somebody that's looking at making thousands of dollars of improvements to fix this thing, and they don't have the money. You may want to try reheat dehumidification to drive their house out. But I guarantee you, after a couple of months of paying that high electric bill, they're probably going to approve that proposal that you gave them for a dedicated dehumidifier. So, Jenry Garcia, he says, go ahead, try it, do it, and dry the house out. That's you can put a controller in, you can get it done fairly quickly, and you let them feel the pain points. Just make sure you prepare them for it.
Nice. Very well said. Thank you so much, Tim, for sharing your home, making your home open to all of us. You guys, putting links to Tim's YouTube channel, which you should go and check out. And remember that his handle is the same on all of the social media, which sounds, again, I'm exhausted for you. Thank you very much again for collating all this stuff and being so detail oriented, not just with the installation, but with the tracking of all the stuff that you're doing. You rock.
Thank you.
All right. You guys, make sure that you can comment below if you have any other questions for Tim. I'm going to drag him over if he can to answer some of those questions. If you got them, like to subscribe. Tune in next time.